Area study 2, algebra number structure. So the objective will be to be able to transpose, equate algebraic expressions, be able to solve those ones, and also solve exponential, logarithmics, circular functions, and involved equations, and be able to solve systems of equations, unique solution, no solution, infinitely many solution, and also be able to determine nature of stationary points and be able to sketch. So that's what we are going to discuss in this area. So it will be a series of lessons based on these concepts. All right, our first one will be factorizing, and we're going to look at factorizing, polynomial factorization. All right, perfect squares. So let's find how to factorize this. So this is just, so this will be quadratic factorization. So if you have something similar to this, so that factorizes to a plus b squared. So it's basically you square the first term, and to find the middle term you multiply the first term, the second term times 2, and you square the third term. Alright, these are, we have seen this, but when we have a cubic function, so if it's a negative, let's say we have got a negative. Well, if that's a negative, it's going to be positive, negative, then positive. So that's going to be the first term will be a squared minus a, which is the first term, times b times 2. So that's going to be ab plus b squared. All right, now with a cubic function, so that is a quadratic function. With a cubic function, let's say we have cubes. Let's say we have 3 cubed, a cubed, and also we have b cubed, and we want to factorize that. So we're just going to put a bracket, a parenthesis. So now that's going to be a minus b, and we open another parenthesis. So we're just going to say a squared plus a times b plus b squared. So that's how we factorize when you have something similar to this. So an example based on this concept could be something like this. Let's say we have x cubed minus 27, and we want to factorize this. So to factorize this, it's going to be, so we need to find out where 27 came from. So the cube root of 27. So x cubed minus 27. Well, 27 came from 3 to the power of 3. So by using the same concept, so that is our a is x minus 3. So that's going to be our a is x again, x squared. So x times 3. So that's going to be 3x plus. So our b value is 3. So that's going to be 3 squared is 9. All right, let's have a look at another example. When we have a plus, so let's say a cubed plus b cubed. So to factorize that, again, we open parenthesis. So a plus b, so that's going to be a plus b. So we're going to say a squared minus this time a times b plus b squared. So that's how we factorize. So let's get an example based on this concept or this rule. So let's say we have x cubed plus 64. So let us write the way it is. Like, let's factorize 64. So that's going to be 4 to the power of 3. So it's going to be x to the power of 3 plus 4 to the power of 3. So the whole lot equals to, so our a is x plus 4 and x squared minus 4 times x, that's going to be 4x plus 4 squared, which is 16. So that is how we factorize when you have good cube. Having said that, we need to remember that 3x to the power of 3, b to the power of 3 is not the same as a plus b, or minus, I should say minus. So a cubed plus b cubed is not the same as a plus b, and put in a bracket. Those are not the same, so this is different story. So this one here, we use binomial to find the coefficients, or the Pascal's triangle. So now this one, if I have to factorize that, a plus b to the power of 3 is going to be, well, this has to be, and this forms coefficient, so that's going to be, the coefficient will be, well, 3, so that's going to be 3, which is 0, which is the first coefficient is going to be 3 factorial, 0 factorial, 3 factorial, which is 1. The first coefficient is 1. The second coefficient, because that will form, so this will form a cubed plus 3a squared b plus 3b to the power b squared b cubed. And to find the coefficients, we need to use binomial, which is something that we're going to look at when we are going to cover probability. So the binomial theorem, or the binomial. So that's going to be 3 factorial, 2 factorial, which is 3. So that's how we got that 3, and so on. So it's going to be 3 factorial, or 3 factorial again, and 1 factorial, and which is going to give us, so that's going to be 2 factorial again, which is going to give us again 3 factorial, well, 3 factorial, 2 factorial, which is going to give us 3 again, 3 factorial, which is going to give us 3. So we look more in depth this one, we cover probability. At the time being, let us not worry about this, so let's worry about how to use the formula. Alright, the take-home message is, this is not the same as that. That is actually the message we need to understand. Alright, let's have a look at a scenario where we have to factorize using quadratic. So factorizing. Alright, now we've seen that x squared we have seen that. So let's have a look at an example based on this. So to factorize this, so let's say we have this quadratic function. All right, to factorize this quadratic function, we need to find out two numbers. When you multiply, gives us 12. When you add those two numbers, gives us 7. Two numbers, when you multiply, gives us 12. So that's going to be 4 times 3. And when we add those two numbers, gives us 7. So that's going to be 4 and 3. So we are going to split the term in the middle. We write it into two terms. So that's going to be 4x plus 3x, 12. So we need to factorize the first two terms and the last two terms. The common factor between these two is x. And the common term between these two, the common factor between these two terms is 3. Since these two are the same, we take 1. So therefore, x plus 3, x plus 4. And that's how we factorize this. If we have a coefficient, let's say we have got a coefficient in front of the x squared. Let's say we have something similar to this. So we're going to multiply the first coefficient, the last constant or the last term. So that gives us 12. So we need to find out two numbers. When you multiply, gives us 12. And when we add those two numbers, gives us the term in the middle, which is 7x. So that's still 4 and 3. So we're going to split the term in the middle, which gives us 4x plus 3x plus 4. The common factor between the first two terms is x. So left with 3x, 4. The common factor between these two terms is 1, 3x plus 4. So since these two are the same, we take 1. And that's how we factorize it. And that's it, factorizing.